my name is Nikhil.
My name is Danny, and we're going to do problems on how to do limiting reactants.
Yep. Okay. So for this problem, we are given if 40 grams of molten iron oxide reacts with 10 grams of magnesium, what's the mass of iron produced? So basically, when you write it out as a formula, it would give us iron oxide, magnesium, iron, magnesium oxide. So to start this problem off, we have the 40 grams of iron oxide. So we write 40 grams of iron oxide times. To start this off, we have to go to the mole. So we write 1 mole of iron oxide over the mass of iron oxide. So since we have two elements, we take the mass of Fe and oxide and add it. So that would be 71.85 grams of iron oxide. So now we can cancel out the grams of iron oxide and we are left with 1 mole of iron oxide. So now we go to the mole ratio. So mole ratio of this formula would be 1 to 1 to 1 to 1. Since they are balanced out, that should be right. So to cancel out the mole of FeO, we look at the ratio of FeO. So that's 1. So we put 1 mole FeO. And since we're trying to find iron, now we put the mole ratio of iron, which is 1 mole Fe. So now we can cancel out the FeO out and we're left with 1 mole of iron. So now, since we're trying to find iron, we now go to the grams of the mass of iron. So that is 55.85 grams of iron. And to cancel the mole of Fe out, we write 1 mole of Fe. So now we can cancel the mole of Fe out, and now we shall plug this into the calculator and we get 31.09 grams of Fe. So that's what we get on the first step of this problem. So that is from 40 grams of FeO produces 31 grams of iron. So now we go to the 10 grams of magnesium. So we write down 10 grams of magnesium and we do the same step as this. So now we go to the moles. So that will be 1 mole of magnesium or the mass of magnesium. So the mass of magnesium would be 24.31 grams of Mg. Now we are able to cancel the grams of magnesium out and we are left with 1 mole of magnesium. So now we go to the mole ratio, which is we now look at the mole ratio of magnesium since we had canceled that out. So the mole ratio of magnesium, which is this right here, is 1 mole of Mg. And since we are trying to find the iron, the ratio of iron is still 1 mole Fe. So now we are able to cancel the magnesiums out, mole of magnesium, and we are left with the mole of Fe. So now since we still trying to find how many iron is produced, we put the mass of the iron, which is 55.85 grams of iron, and we can cancel the mole of Fe. We put 1 mole of Fe. So now we can able to cancel this out and we are left with this. So now after we plug this in the calculator, you'll get 22.9, or you can round this up to 23 grams of Fe. Now basically we're done with the problem, but we still have to find the limiting reactant. So if you write it as this, 40 grams of FeO produced uh, 3109 grams of iron. Same with the magnesium, 10 grams of Mg produced, say 23 grams of Fe. So now, since there's two of them, we have to figure out the limiting reactant. To figure that out, you said to look at which one is the least of this. So 23 is the least, and for example, we can say if you have 23 pieces of bread and 31 pieces of cheese, you can only make certain amount of sandwiches because you only have certain amount of bread. So your final answer would be 23 grams of iron. So that would be your limiting reactant.
This is the problem I picked. If 70 milliliters of nitrogen gas reacts with 45 milliliters of oxygen gas, what is the volume of N2O3 produced? Well, first off, you have to balance the equation. So let's do this. Now you have 3 oxygens on the right side, and you have 2 nitrogens on the right side. You got 2 nitrogens on the left side, and you got 2 oxygens on the left side. So now it's an odd balance. So let's start over here with the oxygens. You got 3 here, so let's go ahead and put a 2. That comes out as 6, and you got 4 N's, so that comes out as 4. Over here on this side, we can go ahead and add a 2, and that's a 4, so that's balanced. You can go over here and add a 3, and that would be 6. So there you go. You have a balanced equation. So if we start with 70 milliliters of nitrogen gas, and it's also going to be a 2:2 ratio. So we're going to have 2 mole of N2O3, because that's what you're trying to find, and you have 2 mole of nitrogen, which that's going to cancel out. Now, since this whole problem is 2/2, it's going to equal 1, so you're going to have 70 ml of nitrogen O3. So now we have 45 milliliters of oxygen gas, and that's going to be a 2:3 ratio. So we're going to have 2 mole of N2O3 over 3 mole of N, or actually, scratch that, we're going to do, yeah, you're going to have that, and then you're going to do O2. So we're going to cancel this out, and this should equal, that should equal 30 ml nitrogen 2O3. So this right here is your limiting reactant, because let's say you have 30 iPhones and 70 people want to buy them. You can't buy them all because you only have 30 and you have 70 people. So this right here is the answer for question 30 or 69. And that is my problem.